I'll talk about what is system sensitivity in optical coherence tomography system and how can we take the measurement of system sensitivity. So this is our OCT setup. In OCT setup we have four components basically. One is the source, reference arm, sample arm and detector. So what does system sensitivity means? So it means that if you put here the 100% reflective sample, so here we will put the sample which is 100% reflecting. So whatever amount of light is coming to the sample arm, the back reflected light will be 100%. So if you put here mirror, so mirror is usually 100% reflective. So that's the case. Then and also like if we block the light here, artificially block the light here and calculate the attenuation, how much light we are blocking, as well as if you see with the mirror how much system SNR we get, total blocking as well as the system SNR we get after blocking. So total amount is the system sensitivity. That means how much maximum SNR we can get from this system when in the sample arm we are putting the 100% reflective mirror. So why it's important? Using the mirror that is 100% reflective, maybe we can get system sensitivity around like 100 dB. But if we use the biological sample in the sample arm, if you use a biological sample arm here, that sample will only reflect back 3 to 5% of the power. So not the whole power, 3 to 5% of the power. So if your system sensitivity is not that high, that means that time if you use a sample or tissue or brain or any sample, then your system, the image SNR will not be that good. So it's very important to have a good system sensitivity, usually around 100 dB. Before going in detail, let's talk about something that we need to use. As I mentioned that we have to block some power if we use a mirror in the sample arm, because mirror is 100% reflective. So one thing we need to do is we have to use the neutral density filter. This is the data we take from the Thorla website. So there are different kind of neutral density filter. This is round step type. This is round continuous. You can use rectangular step too. So there are different type. So one thing to mention is that there is different optical density range like this. What to do with optical density range? Say if you have the optical density range, you can calculate that how much light it will transmit. T is here the transmitted light. So say for example if you take one neutral density filter that has the optical density of 2, then transmission will be like T equal to this equation, and the attenuation will be, if we calculate the one-way attenuation is minus 20 dB. If you use the maximum position, that is maximum attenuation of optical density filter 2, then the attenuation will be minus 20 dB. One thing to mention is that in OCT system, so we are sending light in one way, we are sending here light in one way, and then it's reflecting back in another way. So that means light is getting attenuated twice if you use the neutral density filter in the sample arm. So whatever the attenuation we will find here using this equation, we have multiplied by 2. So if you use the optical density equal to 2 filter, that means it can maximum attenuate minus 40 dB in our case. So we have to take care of that. So that's one thing. So say if you have one neutral density filter but you don't know that how much optical density of that neutral density filter has, so what do you do? you have to take the measurement manually. So how can we take the measurement? Say here is the power meter. This is the power meter from Newport. This is the power head, and this is a neutral density filter, NDF. So what you need to do is say we are sending some light over the neutral density filter here, and also so what we need to do first is that we have to take the measurement of the how much light you are getting from the laser. So here is your laser source, and you are sending light to the neutral density filter to the power head. This is our power head, and take the measurement of power. Say this is say 100 or 10 milliwatt, for example, and then use the neutral density filter here. This is the location of the neutral density filter. It will attenuate the light, and again take the measurement of power using the power head. So this is 153 microwatt. So this is the two reading you need to know, that how much power is reducing. So you can use this calculation. This is without neutral density filter. What is the maximum power? This with. So one way is the calculation of what is before or without divided by what is after. So this is 25.44 dB. This is in dB. Now, as I mentioned that in OCT the loud will be attenuated in two ways: during the forward and also when light will be reflected back. So total dB that will be attenuated is this amount. So 52 dB, something like that. So that's the characterization of the neutral density filter. But now, how can we acquire the data? So to acquire the data, as I mentioned, that you have to put the mirror at the sample arm. This is your mirror, and use the neutral density filter in the maximum position so that you know that how much light will be attenuated, and take the data. So you can take the data of 1D data, that is no scanning of the galvo, or you can take the data of 2D, that means it will scan in only one direction. So that's the data acquisition, pretty simple. Now the data processing. The data processing also pretty simple, is that you make the depth profile. Say this is the depth profile here of your data. In x-axis is the pixel number. This is the pixel. Normally how many pixel you have. If you have the 512 pixels, so here will be 512. And y-axis is the intensity in dB. So here 2 points notice is that our noise range is 40, and you have to check the maximum peak. This is the mirror, so it should be sharp peak actually. Also my diagram show broad peak, but it will be sharp peak. So it's 90. So SNR is 90 minus 40, so 50 dB. So 50 dB. So now here comes the final calculation. System sensitivity equal to attenuation by neutral density filter plus SNR. Say for our hypothetical calculation, the attenuation by neutral density filter is 52 dB. Say if we do the calculation, then attenuation by neutral density filter is 52 dB plus the SNR in our hypothetical case was 50. So system sensitivity is 102 dB. So this is the way you can calculate the system sensitivity. Thank you very much for watching this video.